Good afternoon, everyone. Carahsoft would like to welcome you to our Splunk and SigmaX webinar. Carahsoft Technology is a trusted government IT solutions provider, delivering software and support solutions to federal, state, and local agencies. Carahsoft maintains dedicated teams to support sales and marketing for all of its vendors, including Splunk, Cumulus, AWS, Forescout, VMware, and Okta. We are offering 1 CPE credit to those who attend today's webinar. In order to qualify for the credit, you must be actively listening as well as answering any polling questions that will be presented. If you meet all the requirements, you will receive a certificate. At this time, I would like to introduce our speaker for today, Rob Morrow, founder and CEO of SigmaX. Rob, the floor is all yours.
Thank you very much, Emily. We'll switch to the screen sharing portion. Welcome to the webinar today. As Emily mentioned, we do have polling questions sort of before and after the presentation, and then one in the middle so that we can retire CPE credits for people who are interested in doing so. So today is going to focus on our friends in the reseller ecosystem who are looking to maximize delivery of Splunk, and also looking to potentially save some money while increasing your average sale price. So I'm going to kind of frame up the problem a little bit to get started. And the real problem is, the real problem is that the enterprise spends $8.1 billion a year on IT operations, security, and observability. That's a US alone number. The world will generate 27 petabytes of data in 2024 alone. As a reminder, it takes a very long time to transfer one of those. So SigmaX, our core mission is to help the enterprise accelerate critical data, improve data quality, and reduce IT spend on security observability, which gets to things like OpenTelemetry and application tracing and things like that, but also on IT operations. So we're first going to spend the first half of the presentation discussing sort of reseller benefits. So this is business value for both the resellers as well as the customers on the other side of the reseller. So it's aimed at getting you guys armed well enough to discuss these technologies with the customer at a business level. So a little bit of history and philosophy of SigmaX. So when I was the public sector CTO of Cloudera, we and other people, Wes McKinney notably, we kind of uncovered a major data management problem, which has to do with formatting of data. We'll discuss that at length in the second half of the presentation. So we worked on data acceleration proof, and it was against the most difficult types of data, which were, in our case, SIGINT and waveform data. I say waveform data because actually that problem exists in multiple markets. It's not only for classified workloads or IC workloads. It also exists in, for example, healthcare. There's waveform data represented in those data sets as well. GE Health estimates that 95% of data related to healthcare gets dropped because it's challenging to manage. So we collected a proof and executed a proof against using waveform data. In 2018, we selected Apache Pulsar, which was about a year ahead of Splunk. So Splunk actually also selected Apache Pulsar to store its durable version of the data. We did it about a year earlier, having competed that messaging technology against things like Kafka. As I said, Splunk followed us quickly. They acquired Streamlio in 2019. Their reasons, as well as ours, include things like security, 250% speed increase, and data functions in streams. So SigmaX was formed as a corporation in 2019 with the mission of accelerating and allowing query data to be performed directly at the point of ingest at the edge. Edge can have different meanings in different enterprises, but a common ingredient and problem actually is this ability to get data transported and to get analytics executed in a hurry. And you'll see that exists in multiple markets. In 2020, Intel invested in SigmaX. That partnership is stronger than ever. To describe our model, we don't wait for silicon to come out. We design things together with Intel Corporation so that you actually have hardware and software designed to work together. And as Intel and Altera transition into custom fabrication of chips, that's an even more important strategy for alignment with the folks that are doing specific silicon investment. In 2021, to sort of prove what we were working on, we published an academic peer-reviewed scientific journal article that was in field programmable technologies, and it was a world record for parsing JSON data that is now optimized for transport and query. In that environment, we were able to do tens of gigabytes ingested and written per second. That's per second per server. So if you think about sort of the scaling impact of that, it goes far beyond just a single system. The SigmaX team made some critical hires that year, among them a series of ex-Splunk and also ex-Oracle employees. And we've expanded our delivery capability to include cleared personnel for both installation as well as pre-sales. So if you need help with things that are sort of behind the wall, just reach out and the team will be glad to help. That's both on the pre-sale side, but also on the delivery side. So we have folks with clearances that can actually execute those installations for you, which is pretty critical when you're doing things like POCs. So let's get straight to the business value message. Why should you, as somebody who's already successfully reselling Splunk, consider adding in SigmaX? Well, one of the reasons is that you end up with a higher average sales price. It's not just software. We end up moving specific custom devices that you can actually sell across a wide variety of use cases. That's the SigmaX LogHub. We call it the LogHub because it's software plus hardware personality. It's a small device. We'll talk about it later. But you also end up moving clusters of servers. Whose servers, it doesn't matter. It doesn't really matter if it's HPE, Dell, Supermicro. We support all of them. Just let us know which one your customer uses, and we'll happily verify that those two will work together in tandem. For services, SigmaX provides a platform upon which a wide variety of professional services may be offered. We suggest it strongly to customers, but we as a company do not compete with you. We do have providers that do installations. Evlos is a close partner of ours. They do certified installations for us, but in terms of the professional services add-ons that you can do, of which there are many, and they're highly advised toward the customers, we don't compete with you. I guess, fourthly, introducing new technology like this to your customer makes you the trusted partner, but it also narrows the funnel of people who can compete with you as a reseller. If you have SigmaX plus Splunk, plus maybe something like Elastic or whatever, you have a different offering than the next closest reseller to the customer would. And you can use it with new or existing customers to expand your penetration of that customer and make yourself far stickier if there's a recompete. And lastly, there's very attractive margins for both you and for Carahsoft if you decide to execute one of those transactions, and that'll be covered in the contract language that we can discuss later. So maybe we'll spend a couple minutes talking about why your customers need SigmaX and what the benefit is. They get an immediate beneficial cost and data quality boost in Splunk and in network and server workloads. You get a lot more control over your Splunk Elastic budget and forecasting because the data that moves up for indexing under those tools is now user managed. So you get to decide what data gets forwarded. And we'll go over why that's important when we get into the data management strategy in the second half of the presentation. You also get to eliminate meaningless data. What's meaningless data? Well, in one situation, maybe it's duplicate records. In another one, maybe it's things that are needed for infrastructure, but they're not critical for data management, and they don't really provide any value to the analytics. And there's a slide for that as well. We also have some new capabilities, which include the ability to pull that data from a variety of sources, whether it's querying the edge itself, or whether it's sharing that data via gRPC out to tools like Kubernetes or containers or orchestration workloads. Some of the commonly used data functions, logs, operations, security, there's actually more than this that should be offloaded. We'll cover what more means a little bit later, but a lot of us have gotten used to embedding sort of infrastructure data IT operations inside the servers that we're managing. That's actually not a great idea. for a variety of reasons. One is that it gets in the way of transacting and generating revenue. Another one is that you've now got users competing with infrastructure, and that should never occur. So those should always be offloaded. They were probably always more appropriate for something like a software and silicon workload, but the industry is now offering these. I guess the other one is that one of the big differentiators between us and something that's just a messaging only system is that we go to FIPS 140-2, and we can include transport layer security as well. But the biggest message is that you can save the enterprise and make it massively more efficient if you just prioritize the data as it's received and then move the highest value data at the fastest possible rate. Not to mention, the customer saves 40 to 60% on paying for what is really just compute waste anyway. That's not value add, and it doesn't matter what tool sits behind it, whether it's Splunk or Elastic or something else. You're not really adding to the customer's revenue goals just by wasting compute cycles. And so we'll talk about that a little bit later as well. So I guess the last category is for our partners and partner systems integrators on professional services. So this sort of gets to the what's in it for you. There's actually quite a bit of room for managed services versions of our two products that sort of work together. One is called Rapid Streams. You should ask us about that. We won't compete with you, but we will support you. There's last mile custom data integrations and AI models. We work on standing up the ability and the data plumbing and making everything as fast as possible. And we open up quite a few spots for doing additional value add work via professional services. For example, once the data is in something like PyArrow, you've now got all the data frames. And so now you just need to decide what model that you would like, what models maybe it's plural, that you would like to compete for the customer and deliver so that you can down select the more interesting data before it ever gets into the SaaS cloud offering for processing. What we don't want people doing is taking their very high value data and standing in line waiting for low value data to be processed before it ever gets even observed. We're trying to surface that data much sooner in the value cycle so that you can actually get faster mission value out of the data. These are container-based builds, and so it enables DevOps and DevSecOps, both at the edge, the place where the data is taken in, and also in Pulsar, which is actually managing the durable version of the data. So there's actually two places for you to insert value on professional services. There's physical as well as logical security. By physical security, what we mean is we're actually placing a server inside your server. That's what's on the far left of your screen. It's a small card that just gets inserted into any supported rack mount server that you like, and it offloads all of that. There's physical separation. That device is only used for electricity and airflow for cooling. So you can put it in any rack mount server you want. So that's the physical layer, but there's also logical security in the form of transport layer security as well as FIPS. It's also very easy to expand any tier. You can either expand the very fast moving data via memory in the LogHub itself, or you can expand the durable version of the data. The durable version should be thought of as a scaling tier. So the LogHub itself is going to just move data as fast as possible. It's faster than the line rate. But what's on the other side is how do you scale that data if you had hundreds, thousands, or millions of consumers of that data that gets produced? Well, the first thing that this solution does is writes a durable copy of the data to Apache Pulsar in our AIML enabled platform called Rapid Streams. So then you're able to mix and match streams and control access to real-time data via subscription. So it's very boring from a user perspective. It just looks like a subscription to data. But the insertion of value occurs when you decide to merge those streams and execute things like data functions. It's also easy to expand to either tier. You just add new devices, and it's very simple to expand. So how do you get customers started? So first steps is initial briefings, which we're happy to support any customer briefings that you like. But we recommend that people try to schedule a paid customer POC. Our POCs are $210,000, fully licensed, both sides of the equation. It includes installation and a proof software license for up to 1 year, as well as sample LogHub units. These are evaluation licenses. They're not used for production, hence the compressed cost. And we would like to see 10 servers supported in the POC. Sometimes we can compress that a bit. So just let us know if you have customer POCs. They run very quick. The reason why we license it for so long is that customers sometimes need longer time to make a decision, particularly in the federal government side of things. But once a POC is successful, what you can quote for minimal install of software for hardware is a minimum of 10 servers. We prefer rack mount, but we can work with you on other types. The rack itself, network storage, LogHub devices. We don't offer these devices. That comes from that hardware quote comes from the other partners in the ecosystem, whether it's Dell, whether it's HPE. The customer just gets to choose Cisco, UCS, things like that. But what you would add to that is a software license cost. Retail price for us is $13K per server year. And that's for servers in the Rapid Streams cluster. And then the LogHub system itself. So those are small cards. As we said, you can put them anywhere. The software license for that is $2,500 per LogHub year. So let's talk about why we needed to make something like this. So the world's data is growing at an alarming rate, and centralizing data in hyperscalers is actually going to make that problem worse as customers compete for bandwidth, processing, and storage to the hyperscalers. In a world where it's generally accepted that containers and microservices at the edge are more agile over monolithic servers, which of course they are, we're all still waiting in line to stuff data into the same pipe and the same storage tier as everyone else. And usually that's a hyperscaler, but that's typically would be better thought of as at the end of the processing pipeline and not the beginning. We at SigmaX think the opportunity for drastically improving data flow has really been here all along. It's just been waiting for the software that can glue it all together. And as a reminder, we're really talking about infrastructure logs here. So there's not an operating business on the planet that has ever made $1 from infrastructure logs, except on the software sales side. What happens is the network is really competing with itself. So these things like logs, which should really have a different network path, a different optimization plan, they're competing with revenue-bearing traffic, and that's a very bad thing. We need to get those out of each other's way. So the centralization of data actually has multiple impacts. Data velocity is reduced, leading to very long wait times for analytic results. Critical analytics, such as cyber events, actually have the longest wait times. Some of that's due to not flagging the traffic early, and some of it due to just it's being processed as if it has the same priority as things like just a everyday DNS request, which of course they don't. You would like to have those things elevated in terms of level of importance. Well, what if we didn't have to wait? What if we could speed up data while decongesting the network and saving a lot of money on high-level security analytics and other IT operations analytics by managing the data more smartly? We do believe that there are great use cases for the hyperscalers. We use them all the time. We tend to use cloud to save money and archive aging data. We don't use it for business critical data. That's usually best kept in memory and moving at high velocity, at least until it drops in priority. But some of the interesting problems that not having the data prioritized brings up is things like data velocity impacts cyber event detection. It's an industry-wide problem that it takes 78 days to detect a cyber event, not resolve it, to understand that you have one. That's billions of dollars a year worth of undetected risk of really unknown size. And then it takes an average of 200 days to resolve a cyber event and finally understand the damage that it's already caused. And that's an additional millions per day in unresolved risk. And it's per enterprise. Each enterprise has that same risk. But if we're doing our jobs correctly as data managers, we should be able to fix more than one problem at a time. A silent killer of performance is the largely uninstrumented list of problems caused by using poorly optimized data formats. For example, 80% of wall clock time is currently being wasted by moving data in older sort of file-oriented formats that really aren't ready for anything. They're not ready for computing. They're not ready for networking. They're sort of slow tier optimized. They're optimized for at-rest data in storage. And that applies to a number of different types of formats. A storage-oriented format is not going to be appropriate for network and compute orientation of the data. So this one change over to a modern format impacts speed, scaling, and it does reduce overall IT spend. Part of the way that it reduces that spend is by eliminating the 4 to 16 copies of data that must otherwise exist if we don't modernize the data format. And it has real-world impact. For example, we witnessed a 57 increase in data rates for our US Navy POCs, but outside of the specific customers that we work with, IBM separately improved Python performance by 57x using the exact same data formatting. That's not a coincidence. This uninstrumented problem has been there for a very long time. We've also proven that nearly all predictive algorithms become less useful over time. We refer to this as predicted decay of the algorithms. And basically all that means is that data velocity and time to compute has its own value proposition. As a reminder, SigmaX has yet to see a customer problem we can't accelerate by at least 20x on throughput and 100x on the latency dimension. Every single customer we see, every single POC we execute has had that same benefit. I say 57x, those are real world numbers. In terms of solutions that have already been optimized, we still see 20x throughput and latency increases, 20x on the throughput, 100x on the latency. So I think we need a brief pause to allow Emily to ask her polling question.
Thank you, Rob.
I'll give you guys just a moment. So let's drift into the solution a little bit and describe the problem in more detail. How about if we talk about how most enterprises spend way too much for analytics? So assuming all your log data goes to, for example, Splunk Cloud, wouldn't you agree that not all data has the same value for analytics? How about things like duplicate records, which sometimes number in the millions? And what about the changing value of data over time? Most solutions don't even recognize that data value changes over time. I'll give you a specific example of that. Like if you look at application servers, container communications, application telemetry, those are very high short-term value descriptions of pieces of data. And they're just categories of data. They're somewhat arbitrarily defined, but they all have different value propositions, both on short-term and on long-term view of the data. For example, container communications, incredibly high, incredibly important for the short term. In the long term, that value drops to very low because it's no longer application tracing information. It's now just historicals. You might want to keep that historical data, but it probably needs to go to an archive in something like a cloud environment or a hyperscaler. Do you need to keep that data in memory after long periods of time? And the answer is no. And that drifts all the way down to things like DNS requests and responses. That's a public database, and it's guaranteed not to change over the next 90 minutes because that's usually the time to live for those records. So you might have things that you want to replicate or even accelerate, all the way down to things that you would prefer to actually eliminate because they don't create value in the enterprise. Tracking every DNS request and response is only really useful if you're looking at things like man-in-the-middle attacks. It's not really useful for long-term storage. So you might seek to get rid of that information in the data that gets forwarded to an analytic tool, something like Splunk. What we know for a fact, and this is outside of our company, this is people like Gartner, et cetera, is that there's definitely 40% reduction in software costs and in storage of that data cost in this example. Gartner actually uses a number of 60%. We at SigmaX know that data's value changes over time, and the user ought to be able to define and accelerate the most valuable data, but also save a lot of money by sending the right data up for analysis in the correct order. We think that by learning the specific value of data, you can determine which of those strategies you require, whether it's acceleration, replication, reduction, or sometimes even just outright elimination of that data. It just doesn't add value. So I'm going to start an animation here, which is not going to be done by the time I finish talking about this slide. So why would you ever do this thing? This thing is really making a lot of memory copies of the data, which everyone's been doing for a very long time. To illustrate the severity of the problem, the value of an individual piece of data is typically mixed with other data, but not yet stored or sorted as to its value. Well, the problem is data value is highly variable. What's not good, especially for highest value data, is a lot of data copies that don't add to the business value. What's currently deployed everywhere is a non-optimized model that leads to data sprawl, really costly in-memory copies of the data, and very high wait times. So let's say in this illustration that you're really looking for the high value red bubbles. Well, to get both of the red events, you have to wait for the network to move the data, 4 to 16 in-memory copies. I've chosen 4 because I just don't have the patience to watch 16 copies build up. You got to go back to the network, and then ultimately you can execute a query operation. Each step gets progressively slower and slower. And there's definitely a better way to do that. It's format the data for both network and compute at the same time, and then offer direct query at the point of ingest, while also saving off a durable copy of that data. So that's what SigmaX does. So we fix the priority ordering, the copy and convert problem, and then also a direct query environment. So maybe we'll spend a couple of seconds talking about what we learned really during the big data era, which I think is still going on. What we really learned was applications have a direct affinity for the data they thirst for, but physics really limits how much data can be stored. And the network itself is actually a finite resource. So wherever the data gravity is highest, such as the data center core and inside the hyperscalers, that's when the problem really starts to show up. So the take-home message from that era was, you always send the compute to the data and never the opposite. The strategy should be move less data, prioritize the data you do move for highest business value to achieve the fastest movement to analytics. Nobody wants to wait for a DNS request resolution to get in the way of their cyber analytic. So how do we do this? It's pretty simple, actually. We characterize and format the data early, ideally at the data ingest point, so that the compute and data waste isn't proliferated and copied 16x downstream. So this is just a short side note that our solution actually works best if we understand the customer specific data. And we have a tool to help you get through that. There's a data profiler tool that we offer. It's absolutely free. So you can work with one of our team. They'll get you the free copy of that profiler. That profiler is intended to look at your data, your schema, your data descriptions, and then produce an analytic that tells you how much value you can compress into that footprint. It also gives you a cost over time. So as long as it can be, as long as the data can be described programmatically, it can be accelerated. We typically look for RFC guided things because that means the ecosystem is decided that there's a real description that ought to be universally applied. But more importantly, we optimize the data processing of your data exactly where it sits. Feel free to bring us any of your data problems, even if you think it can't be accelerated. That profiler is free. It just helps you estimate the value of the platform and why you would want to execute a change like this. So sample output is on the screen, the total cost of ownership, power usage, all of that stuff. Again, the software is embedded with this, but sometimes it comes with an infrastructure change that you might want to model out for the customer, how much money they're going to save over time. So what does the actual solution look like? The solution is, let's say you have a few racks of servers in the data center already. That's represented on the left. That's just any system of servers in any core environment, any cloud environment. You've got a few racks. And then maybe you've got a Splunk or Elastic Cloud instance that currently ingests all of your log data. By placing one or more LogHub software appliances inside the server that exist in the data center, you can now accelerate all your log data while offloading log jobs, getting them out of the user's way, and making data flows more secure because there's not this footprint that can be erased in the snow for the logs. It's configured to do one thing very well: take in RFC 5424 syslog logs, optimize them, and share them both in memory and on the network. when the LogHub writes its now modernized data to rapid streams, which is really just Apache Pulsar with AI/ML enablement, it also offers that same data to users as subscriptions to a stream. So as we discussed earlier, the left side is the inbound data. The LogHub lives inside that inbound data destination, but it's secure and separated from that destination. It writes a durable copy so that you can then share that data with millions of concurrent users if you want to. But it also provides that as a series of subscriptions to a stream, and it creates an in-memory SQL table and reduces cloud software spend significantly. It also offers that data via gRPC, which is great news for Kubernetes and container users, so that you can get multiple APIs against the same data in one centralized point. It doesn't take any new rack footprint to operate the LogHub. Your existing rack is just fine. You literally just drop it in. It consumes far less energy than a server does, and this is on the order of a few percentage points of what a server would. 70% cheaper than a server, and it's updatable via container, so you can actually blast out updates to those LogHubs in the live if you like. The summary is that you end up with a reduced Splunk bill of 40 to 60%, and the data moves a minimum of 20x faster. It's also a lot more scalable. So why won't the same thing work with something that really is just a central executor like Spark or a database like MySQL? Well, let's talk about that. So here's an example of why this model works and is always faster, even on a much smaller compute footprint. So using the old way, you'd have to wait for a number of wasteful steps to complete prior to executing a query. First, let's assume that your data is 50 gigs, and that's how much data you want to ingest, and that you got a 10 gig capable network. Well, you'd have to make a few round trips to get that 50 gigabytes of data uploaded. You'd have to wait for the newly ingested data to be copied and converted 4 to 16 times. Then the network moves the data to a SQL-capable platform. And finally, a costly client-server connection is now set up. That client-server connection is not to be underestimated. It's quite expensive. With SigmaX, those data copies are unnecessary. So we don't need to do that. But we also only send the data relevant for the query. You do not need to move 50 gigabytes of data to answer a question of, do I have the zip code 20135 in West Virginia, Maryland, Delaware, or Virginia? It only exists in one place. So everything else will be a flight response of null because there's no data to send. There's no relevant data. The only system that would send the relevant data is the one that actually has the target data in it. So you can query the LogHub itself for the most recent data, and you can also query rapid streams for a full view of the data warehouse. But you can also archive the data off the cloud for lower cost retrieval using the exact same APIs as the real-time data starts to age out. So it's the same APIs, just reduced cost, and it has an infinite archive, so you can store records back to the beginning of time if you choose to use the cloud option. So one more thing, as you might have imagined, about what our plan is here at SigmaX, is that SigmaX is really data-aware software in silicon, and it can be stacked for easy delivery of unique software purposes for accelerating data. So each appliance leverages common network and compute components for rapid installation of accelerated software that's purpose-built. In the LogHub example, you simply supply an IP address, and then you point your servers to that logging location and watch your data get faster. For example, while a customer might only need 1 or 2 syslog accelerators per rack to expand our thoughts around the ecosystem, perhaps they also want to include something like OpenTelemetry or switch and router symlogs. They're all going to scale, they all run at an alarmingly fast data rate, and they all save money on both hardware and software total cost of ownership while adding no new rack footprint, and all at around 150 watts per server per system versus $2,800 per server. It's just using the same servers you already have, and it does it faster. One thing I'd like to point out about this is there's a safe harbor statement on this slide. That safe harbor statement is an indication of what we could build next. So that safe harbor really just covers what will we build next in what order. That's our choice to make. So likely going to be OpenTelemetry, though. I'm just going to give you a hint there. So how about if we dive into the weeds a little bit and see what's inside this server inside your server? So there's 2 components to our solution. The first component is the LogHub. So the LogHub modernizes your data by converting it into a columnar format that is already optimized for both memory and network. It's the same piece of data for memory and network. So no more need for 16 copies of data or even 4 copies of data. It's a single copy. You can move data using IPC format. You save a lot by not making all of those copies. The software in Silicon does all the conversion for you, and then it passes batches of records. And this is all over PCI at wire speeds to a Rocky Linux implementation. This is all inside the same LogHub appliance. That device first writes a save copy out to Apache Pulsar, but simultaneously offers that data for sharing via SQL query, gRPC, and also Aeroflight. This design offers extreme speed, a more modern data structure than something like an append-only log, such as syslog, or even some streaming services like Kafka. But it also offers the ability to very simply and cheaply scale up or down at a controlled cost. Since the data is now organized as streams, it is incredibly easy to simply subscribe to a channel of interest. Maybe not all users want all channels. Maybe you only want the alerts and the truly critical items. So the top half is the very fast wire level parsing, conversion, and batching engine that we build. And we marry that into a data sharing engine that lives in the same small device. That data sharing engine is what publishes the data, makes it available as a SQL table, and also writes a durable copy to a publish subscribe system. Our second component is called Rapid Streams. So Rapid Streams is SigmaX's AIML real-time friendly version of Apache Pulsar. Remember, Apache Pulsar is what's also the Splunk DSP. They're the same thing. So one of the ways to control for what data gets sent up is simply through basic georeplication. That data that the user decides needs to get replicated into something like Splunk or something like Elastic, that's controllable by the user. So you don't have to thrash your licenses and provide incorrect estimates for the data. You just manage how much data goes into the environment. So as a publish subscribe platform, it allows for sharing data with millions of concurrent users. Thousands of compute nodes are supported in a single cluster. You're not required to use thousands, right? It starts with like 10, but it scales to thousands of nodes in a single cluster. It includes serverless functions against the data so that you can combine data from different streams and automatically produce new streams and new data functions. You can combine that data to produce much higher level analytics, such as common operating pictures for Navy workloads or Army workloads. But it's also FIPS 140-2 secure data. And Rapid Streams works together with the SigmaX LogHub to provide a single turnkey solution for logs, but not only logs. Rapid Streams can also host things like rehosted Kafka workloads, host real-time message queues, and can be used to execute serverless functions. Embedded streaming data functions unlock a host of new business value on its own, both for product teams, but also for professional services teams. So I think we should spend the last 11 minutes or so handling questions and see if the team has additional questions they would like to ask, or I can go back and we can look at the solution slides as well. So I'm going to pause and see if there's any questions.
Thank you, Rob. While you're looking at the polling question, I'm going to provide a question over to Rob. So Rob, we have a question here. Is there an interdependence on the host server operating system?
Good question. There is no interdependence on the host server operating system. You can run any operating system on the host itself. Maybe we should describe what we think of as a host. So a host from our perspective is just a server in a rack that's been happily running its workloads for years. And let's say that these are Linux servers. The only restriction on the host would be on the type of data that it sends. You can place this LogHub device in any one of these servers, as long as there's physical room, electricity, and cooling. then it'll work in any one of these hosts. So it is not tied to the host. Maybe we should talk about the system too. So the LogHub itself has its own memory footprint, both the formatting, conversion, and parsing of non-optimal data into optimal data, but also it has its own operating system that's in a secure version of Linux. But there's really no dependency at all on the server that it lives in. It is a network citizen on its own. It is its own server. It does one thing very, very well, and that's process RFC 5424 logs. A second version of that question would be, what about who sends the logs? So we're currently offering a Linux Unix version of syslog data. We will absolutely expand that to include Windows events data, but that's really more about the quality of the character and quality of the data and who generates it than it is about the host that it lives in. It can live in any host that has enough physical room and electricity and cooling to support installing the card in. And it's just a single wide double height card. That's all it is, like any other card, like, for example, a GPU. And it has similar traits to those kinds of accelerators as well. Rapid streams can be run on a number of different things. You can run it on rack mount servers. You can run it in containers. It's a cluster of servers that operate as one unit to replicate, copy, and then optimize your data and run AI ML models in it. The LogHub itself has no dependencies on the host whatsoever. Some of the additional properties of the LogHub are it can move up to 200 gigabytes. We're going to also offer a lower cost version of that, but you can move up to 200 gigabytes through that one LogHub instance. So it's incredibly powerful, more powerful usually than is required by a syslog system. That's why we're looking to put additional workloads on this. But the way to think about it is, scaling wise, is maybe you aim 10 syslog servers, just 10 servers that are generating syslogs at one of these appliances, and then it's time for another one, depending on the amount of log data that your servers all send. You can send as many as you like. It's just an optimization task for aiming data at the syslog server parser, and then the analytics that it goes out to on the high side. Do you have any additional questions for me, Liesl?
I do, and I think that you touched on it a little bit. So the first part of the question was, what does the deployment look like? And I believe that you've answered that question, as well as, is there a dedicated box in each rack with this card in it? But there's an additional question that I think would be good for us to understand as well. One of our participants is asking, should there be one card per server?
Good question. No, there's not required to be one card per server. Now, you might want to think about one card per server, especially when you get into the future version of us that actually has multiple infrastructure software functions included in the same build. So that looks like this. No, you could do, if you decided that your logs production rate supports the idea of having 10 syslog servers aimed at a single card, it's just about the data rates. So you could aim 300 at it. It's about the data rates. So you just don't want to overwhelm it. But right now we're looking at 5-to-1 or 10-to-1, meaning 5 servers generating logs for every one device. And as we look to optimize, it'll be 10 servers generating logs to one LogHub device. What might be interesting, though, is as you think about future versions of what we're planning in the roadmap. So like, for example, if you had one doing log analytics and it was just dealing with syslog data, and then you had another one on the Windows side of the house dealing with Windows event logs, you might want to have a different device for the Windows side, and really just to separate the east-west traffic. But additionally, there are other use cases that this infrastructure is already doing that are probably inappropriate workloads that you might also want to offload. Like, for example, clickstream data, shopping cart data, cart abandonment, churn analytics, things like that. That is an infrastructure task. It's not really directly generating revenue. It just provides you clues as to how you can optimize the customer experience. But the same thing applies to other infrastructure data processing such as open telemetry application tracing. So if you want to know if, for example, Java garbage collection is starting to heat up, or you've got memory back pressure on this system, that system, or the other system, and that's getting in the way of generating revenue for your business, that would be a good idea to maybe carve out an additional slot for something like accelerating those infrastructure functions against not only log data, but other kinds of telemetry. So to summarize, the TLDR version of that is, no, you're not required to run one per server. You can run however many the data tells you to run. So it might be 10 servers to one, it might be 20 servers to one. We will absolutely help you with sizing those based on how chatty your logs are.
Thank you, Rob. We have another question. Can you quantify the reduction in latency in analyzing data at the edge versus in a centralized data server?
Yeah, so our analytics that we ran in our benchmarks, and again, it's published in a scientific peer-reviewed journal article, we competed the fastest version. So the fastest version of that data movement is going to be within the system. So what we competed against with our latency claim, and it's stood up in every single use case we've got so far, is the fastest version of Apache Pulsar versus the accelerated fastest version of Apache Pulsar. Pulsar is already 250% faster than Kafka, so it's already the fastest version, and that's been repeated in multiple benchmarks. Maybe our friends at Confluent would argue, but I don't think anybody else would provide an argument against that case. So we competed against this fastest possible version of what existed before we existed, and we're 100x lower latency on that system. So that means accelerating the data as it's ingested. And to be honest, most of that is data formatting. It's just that people are using the wrong formats. They're not using compute-ready, wire-ready formats. It's creating all of these little data babies. So the data babies are what get in your way of making a faster system. But also remember, we're moving data at the speed of wires connected to wires on the PCI side, which is a very fast data rate. We're not moving that data at the speed of a message floating across the network to a hyperscaler. They're always going to be fast when you're talking within the hyperscaler. So let's say you're using something like Oracle Cloud or AWS or Azure or something like that. They're going to be really, really fast once you get the data inside that environment. The challenge is getting it in, and usually there's a cost associated with accelerating that data. For example, I know Amazon charges for things like Site Link and Direct Connect, which are really just network enhancements. It's just a wider pipe. So what I'm arguing is that it doesn't matter the width of your pipe. If the data is not optimized, it's still wasteful either way. And 57x showing up in multiple different contexts means it's a very repeatable result. Not even when we're not doing it, when IBM does it, when somebody else does it, it's still a very high value system. What we think about the cloud and the high-level analytics is for getting centralized data in, keeping it long-term. But I think something needs to be done about duplicate records, about just sort of data sprawl that goes from ingesting 800 gigs per day to a terabyte per day. Those are frequently common costs that the customer just has to get surprised by and then try to figure out a reactive strategy for it. What we're suggesting is that not that the customer should cut back on their spend of any of those high-level analytics like Splunk or Elastic, but that it's manageable, because all we do is determine what level of replication is needed for now. You can still save a local copy of that data, right? So it's the user who decides what data gets replicated and not replicated. So it's all within your control what your actual spend on high-level analytics is.
Wonderful. I have another question for you. Does Splunk SigmaX work in a hybrid Splunk environment? Meaning, if I have Splunk and Elastic in the same environment, am I able to send specific data to each platform depending on the mission requirements?
Absolutely. You can connect it to any tool. We connect it to both typically. So the solution right now for just syslog, and there'll be more as we talk about future solutions, So the solution for syslog can be applied in both directions. So you can have the same system connected to both Splunk and Elastic and at the same time, or other tools like Datadog. Maybe we should go back to this diagram here that talks about what's on the other side of the analytics. That's a swappable set of components. It's aimed at Splunk and Elastic from an optimization perspective, but it'll work on any set of tools, Datadog, really anything that leverages either Aeroflight, SQL, gRPC, or other data transit mechanisms. And they're all fast. It just needs fairly modern tooling on the analytics, and they're both modern. They're all, everything in here is modern.
Great. And we've got
Or data, you
one.
can take it wherever you want.
Thank you, Rob. We have one additional question, and I'd like to open up the Q&A session. So if anybody that's participating has any additional questions, please put them in the Q&A section so that Rob can answer them. The question that I have now is, are there existing solutions like this in the market, or is this a new paradigm?
It's probably a new paradigm, although I don't know that there's a good reason for it. This technology with Aero and Aeroflight, which is really what we're describing here, is getting the data ready for the most useful versions. That's been out for a while. We're talking about, years at this point. So I think in order to benefit more from eliminating all the copy and convert stuff, it really deserves some attention, and that's the Apache Aero stuff. So we gravitate pretty heavily toward Aero and Aeroflight because we believe it's the right way to save the customer a bunch of money and speed up all your data. So far, it's working everywhere it's deployed. It really is a bit of a paradigm shift, because what we're really talking about is those functions, those infrastructure data functions that are already in your customer's way. You're really multi-purposing a server that shouldn't really be doing all. So the systems that generate syslogs, the systems that generate clickstream analytics, they're all the same systems right now. What everybody does is they tend to load up a lot of endpoints on their servers, which is fantastic, until it gets to the point where your server is actually doing more infrastructure than it is processing revenue-bearing transactions, mission-bearing data, things like risk. That stuff all needs to get out of users' way. So it's a bit of a paradigm shift, because what we're talking about is a small appliance that does one thing very, very well. It does share the data. It can be shared with anybody you want. But instead of turning your server farm into sort of this plaid multi-purpose system, you tend to make your servers a lot more efficient and allow for them to process revenue-bearing items, because they're not then spending every third cycle doing infrastructure management things. So it is a bit of a paradigm shift.
Thank you very much, Rob.
Thank
we
you.
don't have any additional questions at this time.
Okay, I will stop sharing. And Emily, if you'd like to help close us out and deal with any follow-up items.
Thank you, Rob. I would like to thank our participants as well as Rob for being with us today. We hope the information you received during this webinar has been helpful to you and your organization. As a reminder, everyone will be receiving a recording of the presentation in a follow-up email. If you have any questions or would like to request more information, feel free to contact the Splunk team at Carahsoft. Our contact information is displayed on your screen, so please don't hesitate to call or email us. If you would like to provide feedback on today's webinar, a few survey questions will be on your screen momentarily, so please stay on. Thank you and have a great day.